Okay, friends, so this is our second playlist for our introduction to confidence. Starting next week, we get into the nuts and bolts of how to actually construct these margins of error, like in great detail. But I wanted to kind of bridge the gap between what we just did in the previous set of videos and that one by kind of digging into some statements that I made in that last playlist of videos that I was thinking about after the fact. I said, those probably deserve a little bit more explanation. So let's get into those now. Okay, so why does that make sense? Why, when I was Googling around looking for examples of confidence intervals, did I see so many that were based on the sample proportion instead of the sample average? And really, the answer, I don't know the answer with certainty, but I have an idea. P hat is a probability. It's a percentage. You count a number of things and divide it by another number of things counted. So these are successes or failures in an experiment, like heads on a coin, or broken legs on a ski resort slope, or incidences of a certain disease. You're trying to get the incidence rate of a certain disease. These are countable things. Each element of your sample either has or doesn't have that property. It's binomial, to use a fancier word. So these are countable. It's very easy to count things, exceptionally easy to count things. Now, with an average, we know the formula for average is you add up all the data and divide by how many data points there are. That's the general form of an average. But the question is, how do you get these data points? Yes, this is just adding up your sample size, how many elements are in your sample. But the question here is, how do you get those data points? So say, for example, we're talking about the average temperature for a given locale. Well, temperature, you don't count temperature, you measure temperature. And as soon as you get into measurements like temperature, you have to have specialized equipment. Now, granted, a thermometer is not super specialized, but it's a piece of equipment that you don't need when you're counting something. So my theory as to why you so often see percentage confidence intervals versus average confidence intervals is really just ease of collection of the data. Much easier to count than it is to measure. So that's Sean's ruminations on P hat versus X bar.